the Chapter 2 review. Starting at number 1, I want to first draw what these graphs look like. So y equals x squared is a u-shaped. Y equals x to the third. Looks like that. Square root of x goes like this. Cubed root of x goes like this. And absolute value of x is a v. Okay, so we had to do the odds. Number 1, true or false, the range of x squared, okay, range would be greater than 0, is the same as this one. Say yes. X is greater or equal to 0 for both of those. Number 3, the square root of x, which is this one right here, and a cubed root of x, both right there, have the same domain. That's false. Square root of x, the domain would be x is greater than 0 or equal to 0, and the cubed root of x would be all real numbers. Number 5, x has a domain equal to its range. Okay, so x, the domain is all real numbers, and the range would also be all real numbers. Number 7, none of the basic features decrease on the interval from 0 to infinity. So 0 to infinity, this is increasing, 0 to infinity increasing, 0 to infinity increasing, 0 to infinity increasing, 0 increasing, 0 increasing. True. Number 9, both x squared and the square root of x have graphs that are symmetric with the y-axis. X squared, symmetric with the y-axis. Square root of x, symmetric with the y-axis. Good, that's true. Number 11, give the interval described. Okay, so we have the domain of the square root of x. So the square root of x looks like this. Domain goes from 0 to infinity. Well, it includes the 0 there too. Number 13, the range of the cubed root of x. So cubed root of x, we said looks like this. Okay, now the range, this will keep going down and that'll keep going up. So it's all real numbers. Or from negative infinity to positive infinity. Okay, so we have the cubed root of x, same graph as up there. Where is it increasing? Well, you can see it's increasing the whole time. Sometimes it's not increasing very much, and sometimes it's increasing more, but it's increasing the whole time. So from negative infinity to positive infinity. 17, the domain of x equals y squared. Okay, so this isn't y equals x squared. This is x equals y squared, which would look like this. Okay, and the domain here, no x is down here, but it starts at 0. So from 0 through infinity. Okay, we want to sketch these. Okay, this 19 is kind of interesting because it's not squared or anything, right? So it's just a linear line. It's really the same as if I combine like terms, x plus 2. So it's y equal x is right here, so if I just take 2 and shift it up, we have that equation there. Okay, so now we have the U-shaped, okay? So the U-shaped, it goes down 2, and it goes left 1. We have our U-shape. Be able to describe that down and over. 23, we have our cubed root. Okay, so the cubed root, okay, so we know what cubed root looks like from right here, right? So the plus 2 shifts it up 2, and the negative reflects it over. So it's going to go like this. Okay, 1/2 square root of 1/2 x. I didn't really talk about this in the inside here. That is actually we just talked about vertical stretches. This is a horizontal and compresses. This is a horizontal compress. So if I horizontally compress it, it's going to get skinnier and fatter. So it's going to kind of go up a little higher with the square root of x. 27, we have the cubed root. Okay, so we know what cubed root looks like. The 2 is going to stretch it out vertically. So it becomes even, sorry, cubed root goes like this. It's going to become skinnier. So it's a yep. No. Okay, it's a stretch. Okay, the 2 is greater than 1. So instead of being like this, we're stretching it out more. So it'll go more like this. So stretching it out just a little bit more. 29. Absolute value is a v. So the v goes down 1 and to the right 2. Okay, 31. We're looking at this graph here, and we want to know where is it continuous. Okay, well, it'd be continuous from all the way from negative infinity to negative 2. We're looking at the x values. And then it takes a break, and then it would also be continuous from negative 2 to 1. Then it's also continuous from here through infinity. So that's at 1 through infinity. So that's where it's continuous. Where does it increase? Okay, it's decreasing here, it's increasing here, and constant there. So increasing in the interval from negative 2 to 1. Notice it includes those numbers, right? Fill it in circle there. C, where does it decrease? This is the decreasing part, so from negative infinity to negative 2. Where is it constant? So here's our constant, doesn't go up or down. So not including the 1, but from 1 out through infinity. What is the domain of the function? Okay, the domain are all my x's. So this keeps going, so all these x's are included. Negative 2 is not included here, but negative 2 is included there. Okay, all these x's are included, 1's included, and all the numbers above 1 are included. So all the numbers are included from negative infinity to positive infinity. What is the range of the function? Okay, so looking at the y's. So our range comes up. First range we have is at negative 2. Okay, you could write so negative 2 is part of the range. Okay, the range also, takes a break then, starts up again at negative 1, and it's going to keep going up until 1. From negative 1 to 1. And then it also takes a break there and then picks up at 2. Doesn't include the 2, but at 2, and then greater than 2 as well. So from 2 to infinity. Okay, so that's 31. 33. What kind of symmetry does it have? Also, is it a function? Determine if it's an odd or an even function or neither. Okay, so this one here, it reflects over the y-axis, also reflects over the x-axis. Okay, and it's also reflecting across the origin because this point will become that point. Okay, so you can see it's going reflecting across that origin there. So this has a lot of different symmetry. It has x-axis symmetry, y-axis symmetry, and origin symmetry. Okay, has all three. It is not a function. Okay, because it fails the vertical line test, right? Okay, each x doesn't correspond to one y. And then also, is it an odd or even function? So since it's not a function, we can't say it's odd or even. It's not an even function or an odd function because it's not a function. Okay, 35. You could approach this two different ways. One way is to get a graph of it. So if you get a graph, it's the absolute value plus 4 shifts it up 4. So we have a graph that looks like this. Okay, so that is a reflection over the y-axis. Okay, it is a function. Okay, and if it's reflected across the y-axis, it is an even function. Now, another way to decide if it's an even function, remember, is if we find that negative f of x and it equals f of x, then we know it's even. Okay, so let's do that as well. So if y is equal to absolute value of x plus 4, so this would be that, which, since it's negative, absolute value is still going to be the same thing when you get it back. So you can see it's equal to the same thing, therefore even. Okay, 37. Okay, so y equals x squared minus 5. I'm not going to go through the graph of this. I'm going to go through the, well, let's do it. Okay, so if I take, to graph this, I want to get y by itself, so I can take the square root of both sides. Okay, and remember, when you take the square root of both sides, it's a positive and the negative. So when you're looking at the graph of this, okay, it's a square root function, and the minus 5 shifts it to the right 5. So that's the positive of it, and then the negative of it. Okay, so that's kind of what the graph is there. It's not across the y, but it is across the x, so it has x-axis symmetry. It's not a function, doesn't pass the vertical line test. If it's not a function, it can't be odd or even. Okay, number 39. The graph of a function. Okay, decide whether it's true or false. Okay, graph of a function, except for a constant function, cannot be symmetric to respect to the x-axis. Okay, if it's just like this last example, if it's symmetric with the x-axis, then it's not going to pass the vertical line test, so that's true. 41. The graph of an odd function is symmetric with the origin. Okay, odd function is, yes, that's true, it's the origin. We also think about the f of negative x equal, with it odd, has to equal the opposite of the original function. 43. Okay, if you think about this graphically, if I have the point AB here, if it's an odd function, we said odd functions across the origin, so it would come down here, and that would be negative A and negative B. Okay, so that is a false statement. Should say if AB, then the point negative A, negative B should be on there. Okay, so you couldn't see that. If I have the point AB on there, across the origin, it would be negative A and negative B. 45. Okay, so we're looking at this and seeing what this does. Okay, so the minus 8 takes it down 8. The plus 4 takes it left 4. The 3 is a stretch, 3 times higher. And the negative is a reflection over the x. Okay. 47. Okay, so our original graph looks something like this. Okay, so that's the original graph. Now, we want to do 47 as f of x plus 3. So it's just going to take everything, take this point here, which is at 0, and it's going to shift it up to 3. Okay, that's shifted up to 3. This is shifted up 3 units, so you get a graph like this. Okay, this is going to come down like this and back up. Okay, so everything's up 3 units. Okay, 49. This is our original graph. Okay, so looking at this, each unit's going to go down 2 and left 3. So this point here goes down 2, left 3. This point here goes down 2, left 3. Okay, so it'll look like this. Okay, this point here goes, it's already at, what, -2. So if it goes down 2 and left 3, it'd be like right here. And this point is at 8. So if it goes down 2 and then left 3, it'd be at 5, but it should be about right there. Okay, so just every point gets shifted down and over. Okay, so that's through 49. We're skipping to 61 now. Was it 61 through 69 odd? Okay, 61. Remember, you're solving absolute value. So absolute value will always have 2 different equations. So that 4x plus 3 could either equal 12, or the 4x plus 3 could equal -12. Okay, so you solve it, subtract your 3 over, and divide. Same thing there, subtract your 3 over, and divide. Okay, and you get your 2 answers. 63. I want to point out 62 here real quick as well. So remember, you have to get rid of this first. When you subtract that over, you have absolute value of -2x minus 6 equals -3. And if you remember, you could set up your 2 equations here, but absolute value makes it positive. I can't have a positive number equal to a negative number, so therefore that's why there's no solution there. Okay, 43. So we got 2 absolute values, got to set up 2 equations. 5x plus 3 is equal to x plus 3. I'm sorry, x plus 11. The other equation would be that could equal the opposite of the x plus 11. Or if we take this as it and do the opposite of that side, so the opposite of 5x plus 3 could equal the x plus 11. Okay, so we have our 3 scenarios there. So if I subtract that x over, I have 4x. Subtract that 3 over, I get 8. And divide, I get 2. Okay, this would be -x minus 11. Okay, now I add that over, I get 6x. Subtract that over, I get -14. So x is equal to -14 over 6, which is -7/3. -5x minus 3. I'm going to take the 5x this way to make that 6x. I'm going to take that over, make that -14. Once again, I have -14 over 6, which is -7/3. It's always a good idea to take them and plug them back in, but they will work. So -7/3 and 2 are the answer. 65. Okay, we set up our 2 equations here. So 2x plus 5 is less than or equal to 7. The other equation is 2x plus 5 is greater than or equal to -7. And you can remember go LA for an and versus an or, right? So if it's less than, it's going to be an and. So both of these have to be true for my final answer. So solving it, subtract your 5 and divide by 2. Subtract your 5 and divide by 2. Okay, so we have negative 6 and 1. Has to be greater than or equal to negative 6. Has to be less than or equal to 1. So if both have to be true, it would be true for all the numbers in between there. In interval notation, from negative 6 to 1. Okay, 67. 5x minus 12 greater than 0. 5x minus 12 is less than negative 0, which is still 0. Since it's a greater than, it's going to be an or statement. Okay. So okay. So if we look at this graph here, okay, 12/5, x is greater than 12/5, x is less than 12/5, okay? So one or the other has to be true. So these numbers work for this one. These numbers here work for this one. So every number will work except for 12/5, okay? So from negative infinity to 12/5 work, and from 12/5 through infinity works. Okay, number 69. Okay, so remember with number 69, we got to get the absolute value by itself first, right? So first thing we got to do is subtract the 1 and divide by the 2. Now we're ready to set up the two equations. So 3x minus 1 equals 10. 3x minus 1 equals negative 10. Okay, so don't forget to do that first. So we got minus, add 1 gets 11, divide gives you 11/3, and add the 1 gives you negative 9, and you have your two answers. You can always take your answers and plug them in when you have a question about that. Okay, number 75 is a piecewise function. We have this for all of our x's that are less than 2. Okay, so over on this side we're going to graph this, which starts at 1, goes up 3, and over 1. So at 2 you'd be at 6 up there. And it's this graph here. For x is less than 2. So 2 and less than 2 we're using this graph. Not or equal to though, so it's going to be an open circle there. Okay. The other equation is going to be for 2 and greater. That would start at 4 and go down 1 over 1, down 1 over 1, okay? But also to find the points, let's just plug in the 2. So negative 2 plus 4 is 2, so it'd be at 2, 2, and it's or equal to. And we do know it goes down 1 over 1, but we could find 3. Negative 3 plus 4 is 1, and you could plug in values and stuff there too. So there's the graph for 75. 79. Okay, we're trying to find f of 1 plus g of 1. Okay, f of 1, so here's our f of x function. At 1 is 2. And g function at 1 is 3. So add them together, you get 5. Okay, number 81. We're finding f of negative 1, and we're multiplying it by g of negative 1. F of negative 1, that negative 1 is 0. And g of negative 1 is 3. 0 times 3 is 0. 83. F of g of 2. So first we got to find g of 2. So g of 2 is 2. Now to find f of 2. So f of 2 is 3. 85. Find g of f of negative 4. So first we're going to find f of negative 4. So f of negative 4 is 2. And then g of 2 is 2. 87. Okay, doing it from a table now. Finding f of 1 plus g of 1. F of 1 is 7. And g of 1 is 1. Add together give you 8. Number 89. Finding f of negative 1, multiplying it by g of negative 1. So f of negative 1 is 3. G of negative 1 is negative 2. Multiplied together gives you negative 6. 91. Finding g of f of negative 2. So first we're finding f of negative 2, so f of negative 2 is 1. And then g of 1 is 2. Okay, 93, your favorite type of problem here. Okay, so we're plugging stuff in here. So we're plugged to find f of x plus h. We're taking x plus h, plugging it in there. So we have 2, x plus h plus 9. Then we're subtracting from that the f of x, which is the 2x plus 9. We have to divide the whole thing by h. If we distribute it through, we have 2x plus 2h. Move it over for you. 2x plus 2h plus 9 minus 2x minus 9 over h. Cross out your like terms. We have 2h over h, which simplifies to be 2. And that is the chapter review.